right, simplifying radicals is our topic for today. Looks like that's pretty visible. So what is a radical? When we use this word, a radical. Radicals, the most common radical is the square root. So if I said the square root of 4, that would be 2. Right? If we were to give a general definition of this, we could say the square root of a number x equals another number y. And I could say if y squared equals x. That's kind of a general definition. And then I could say the nth root. So sometimes you'll see a little number in the root there of x equals y if y to the n equals x. So for example, if I asked you for the third root of 8, we could say, that would be 2 because 2 to the third equals 8. So there's another way of thinking about this, which is, erase these guys, kind of another definition. A radical, if I have x, and remember if there's no number there, we assume it's the square root, right? This is also equal to x to the 1/2. And the cool thing about this definition is that we realize square roots are really exponents, which means, what does that mean? It means that the square roots are going to follow all the same rules as the exponents. So all these exponent rules that you guys already know, they all apply to square roots. Okay? So let's give some examples of that. Say applying exponent rules to square roots. So if I had the square root of a fraction, like 4 over 25, that's the same thing as the square root of the numerator over the square root of the denominator. So this is one way that we might use an exponent rule to simplify a radical expression. So we could say this is 2 over 5. The square root of 4/25 is the square root of 4 over the square root of 25, which is 2 over 5. And for now, we're just going to leave all of our answers as positive numbers. If you think back to that first definition, this could also be negative 2 over 5, because negative 2 times negative 2 also equals 4. But we're going to ignore that for now. It won't be long before we come back to that, though. I'm going to stand off the camera. Yeah.
Isn't that kind of weird? Because, like, if you're doing a radical on, like, a graph, let's say, like, and you can just change it to be negative, like, I don't know, this is kind of weird because it would change the direction for, like, a slope or something.
Right. And in certain cases, the radical answers are kind of assumed to be positive. So with what we're going to learn today, the answers are almost always given as positives. But in other cases, you have to consider both the positive and the negative answer. So I'll always kind of cue you into that and why that is. So here's another rule. If I have the square root of two numbers like 4 times 3, that's the same thing as the square root of 4 times the square root of 3. And this might not look like an exponent rule, but it is a lot like an exponent rule. If you think about this, like if we said, 4n to the 5th, we've learned that that would be 4 to the 5th, n to the 5th. And so the thing to kind of remember is there's like an implied parentheses inside of your square root, and that might help you to see the connection to these exponent rules. So another way of writing this would be 4 times 3 to the 1/2 equals 4 to the 1/2 and 3 to the 1/2. That's like another way of writing the same thing, but no one ever writes it like this. Yeah?
Then if you simplify it even more, like the square root of the square root, would it just be 2 to the square root?
Right. So we could simplify this to 2 square roots of 3. Exactly. Alright. And this is the type of rule that we're going to use the most. Okay. So in general, we're going to use this rule where we have a number. And the way that you'll see this is you'll have a number like 200 in your square root. And in order to simplify that, you have to think of a perfect square that's in 200. So in this case, we know that 200 is the square root of 2 times 100. Or the square root of 2 times the square root of 100. Or, I'm going to move this one out front, 10 square roots of 2. The most common mistake I see with these is people either forget to change the number to its square, so you would write 100 square roots of 2, or they leave it in the square root, so you would have square root of 10 times square root of 2. Both of those are really common errors that you guys will not make on your homework tonight. Okay? So you just have to remember, I have my 100 under my square root, and then I take the square root of 100, leaving a 10 in front of my square root of 2. Okay? So it's not 100 square roots of 2, it's not the square root of 10 times the square root of 2. Those are not the same thing as this. So these are fairly straightforward. You're just looking for numbers that are perfect squares. So if I had like 32 in my square root, I would look for maybe the square root of 16 times 2, which would be 4 square roots of 2. Because I see 16 isn't here. Now, you could break this up in a way that's not helpful. Like if I said the square root of 8 times 4, well actually, this is a little longer, right? So I can do this still. The square root of 8 times 4 equals the square root of 4 times the square root of 8, which is 2 square roots of 8. But I'm not done yet because 8 still has a perfect square in it. So I would have to keep going. Oh, wait a second. That's 2 times the square root of 4 times the square root of 2, because 8 is 4 times 2, which is 2 times 2 times the square root of 2. And now I have to combine these numbers that are not in my square root. So now I finally have 4 square roots of 2. So this is like a longer way, But sometimes you won't always see the biggest possible perfect square. Right? And so if you find a perfect square, you can simplify it, and then you might just have to simplify it again. And that's totally fine, as long as you make sure your final answer has no perfect squares in it. So 2 has no factors that are perfect squares. On the other hand, you could sometimes come up with answers that aren't really helpful at all. Like, I could think of 200 as like 40 times 5, which is going to kind of, you would still get there eventually if you simplified this, but it would be a little tricky. So let's do that example. If I thought of the square root of 200 as equaling the square root of 40 times 5, then I might see, oh, I have a 4 in here. So that's going to be the square root of 4 times 10 times 5, which is 2 square roots of 10 times 5, which is 2 square roots of 50. And then maybe you would say, oh wait, 50 has a 25 in it. So now I have 2 square roots of 25 times 2, which is 2 times the square root of 25 times the square root of 2, which is 2 times 5 square root of 2. And finally, we get 10 square roots of 2. But this is like a really long way. So you want to spend some time thinking about your numbers that are under your square root. And so I want to give you some tricks that will help you to do that. When you have larger numbers. So I'm going to give you kind of some basic tricks, and then we'll extend to how this is going to help. So you probably know some of these rules. So a number is divisible by 2 if it is even. Okay? That's one that everyone knows, right? Like if you look at these numbers, let's say 7,011, 8,462, you can immediately tell me which one of those is divisible by 2. Right? That's the one that's even. So it ends in a 2, 4, 6, 8, or 0. And if it's odd, it's not going to be divisible by 2. So why is that useful? Well, one reason it's useful is if you have a huge square root, 7,011, I know that I'm not going to have any even square roots in there. Right? I'm not going to have a 4. I'm not going to have a 16 because this number itself isn't even. So kind of looking at your numbers and knowing some of these rules is going to help you. So there's some really cool tricks. A number is divisible by 3 if, you guys know this one? If the digits add to 3, or a multiple of 3, to any multiple of 3. So if we look at these two numbers, 7,011 and 8,462, I know right away that this one, because it adds up 7 plus 0 plus 1 plus 1 equals 9, I know that's going to be divisible by 3. And let's just prove that that's true. 3 goes into 7 twice, with a remainder of 1. 3 goes into 10 3 times. 3 goes into 11 3 times, with 2 left over. 3 goes into 21 7 times. And so I figured out that this number was divisible by 3. But 3 is not a perfect square, so this rule is not that helpful. The rule that is helpful is 9. So a number is divisible by 9 if the digits add up to a multiple of 9. We'll get there eventually. A number is divisible by 4 if the last two digits are divisible by 4. So if I had a really big number, like, I don't know, man, these markers today. See if this one works. That one erases. Okay, so if I had a number like 7,321,412, I know this is divisible by 4 just because the last two digits are divisible by 4. Which is a really cool rule because 4 is a perfect square, right? So when you start to see really big numbers under your square roots, and I would probably not give you this problem unless this marker smells like chocolate. I wouldn't probably give you this one because it's kind of extreme. It would take you a long time. But you would know immediately, oh wow, this is divisible by 4 because my last two digits are divisible by 4. And then what you would have to do to solve this is divide 4 into that. 4 goes into 7 once. Right? 4 times 1 is 4. 7 minus 4 is 3. 4 goes into 32 8 times, which is 32, so we have 1 left over. Goes into 12 3 times, with 0 left over. Doesn't go into 1. Goes into 14 3 times, with 2 left over, into 21 5 times, with 1 left over, and it goes into 12 3 times. So then I would look at this number, and I would try to see if that's divisible by any perfect squares. Well, I know it's not divisible by 4, which also means it's not divisible by 16 or 100. Why does it mean that? Because 16 is 4 times 4. So if a number is not divisible by 4, it's not divisible by 16, and it's not divisible by 100. It's not divisible by anything that has a 4 in it. So this rule can really help you eliminate or find some possibilities. We could check if it's divisible by 3 or by 9 if we added this up. 1 plus 8 is 9, plus 3 plus 3 plus 3 is 18, plus 5, that's not divisible by 3 or by 9. So we've already eliminated a whole bunch of possibilities.
What if it's divisible by, like, what if 2 rules work for one number? Which one would you pick?
Yeah, so we're going to talk about that in just a second. So I think everyone probably knows that a number is divisible by 5 if it ends with 5 or 0. Right? I think you guys probably know that. So like 3,425 is divisible by 5 because it ends with a 5. I'm not going to talk about all the rules. There are some other rules in here, but like 6 and 7 we don't really care about because they're not perfect squares, right? 8 is not a perfect square. So we care about 4, and then we care about 9. So a number is divisible by 9 if its digits, actually I'm going to say if the sum of its digits is divisible. And the way that I do this, if I have a really big number, what I do is I look for 9s. So I kind of think, okay, 7 and 2, that makes 9. And then 2 plus 3 plus 4 makes 9. And if I have anything left over, 1 plus 1, I know this number is not divisible by 9. So let's try that with this number. If I had like 7,111,872. So the way that I do this, I look, okay, 7 plus 2 is 9, 8 plus 1 is 9, and 7 plus 1 plus 1 is 9. I have nothing left, so I know this number is divisible by 9. Because I took a bunch of 9s out of those digits, like adding up the digits. It's a little bit weird. It's kind of a weird way of thinking about it. You could always just add up the digits, right? 7 plus 1 plus 1 plus 1 is 10, plus 8 is 18, 25, 27, and then you could think, okay, those add up to 27. 27 is a multiple of 9, so this number is divisible. So let's think of some other perfect squares. And this is not a perfect system. These are just kind of hints that will help you along the way. So we talked about 4, we talked about 9, we talked about, that's it, I guess. So the next perfect square, this is 2 squared, 3 squared, 4 squared is 16. So to see if a number has 16 in it, I would just look for 4s, right? Because it has to have 4s in it to have 16. So I would use that same 4s rule. Are the last 2 digits divisible by 4? And I would just do it in 2 steps. Okay. So I would just use the 4s. What was the 4s rule? A number is divisible by 4 if the last 2 digits are divisible by 4. Our next one is 25. And whenever you see a number that ends in 5 or 0, you want to consider that 25 could be in there, right? Yeah.
But not all things are divisible by 4 divisible by 16.
Right. So that's what I'm saying. These are not perfect rules.
Okay.
Right. Not everything that's divisible by 5 is divisible by 25, but it might give you an indication. So like if the last digit is a 5, I know it's not even, so it's not going to be divisible by 4. But I might consider, okay, this could be one that's divisible by 25 if it ends in a 5. Okay. So use the 5s. 6 squared is 36. I probably should have explained this a little better earlier, but A number is divisible by 6 if it's divisible by both 3 and 2. So if it has to be even, right, to be divisible by 36. And then the digits would have to add up to 3, or a multiple of 3. So these ones, 30 multiples of 36 can be pretty hard to recognize, but they're always even, so that, that has something going for it. And another thing is, guess what? 36 is 9 times 4. So if you find the 4s and the 9s, you're pretty much on your way to finding the 36s. Okay. And so again, some of these bigger numbers are going to be actually easier to do just in steps. Look for the 4s and look for the 9s first. And then you don't really have to worry about if there was a 36 in there. 7 squared is 49. I don't know any good rules for 49 or for 7. If there is one, please tell me. So these are the ones that you might just, the last thing you might look for is 49. Is there a 49 in this? Because there's like no 4s in it, there's no 9s in it, there's no 10s or 25s or anything like that. So you might just say, well, maybe there's a 49 in there. So I don't know. I don't know how to do this for that. But 8 squared is 64. And again, if we have a 4 in there, we're going to bring it down to a little smaller number. So if we use this rule to look for 4s, we might find our 64s. Okay, I don't know a shortcut other than that. 9 squared is 81. Again, just use your 9s rule. 81 is divisible by 9, so if you're using that 9s rule, you will eventually pull out your 81s. And then 100 is a really easy perfect square to find because every number, right, has to end with at least 2 zeros to be divisible by 100. And there are bigger ones, like you should know that 11 squared is 121, but I don't know any rules for finding that. The nice thing though, I don't know if you've noticed this, because of 4 and 9, every even number that's a perfect square has 4s in it. So if you notice the last 2 digits add up to 4, you're really on your way to breaking down those bigger radicals. And then every thing that's a multiple of 3, so 9, 36, 81, those are all going to add up to, their digits are going to add up to 9. So just between these 2 rules, you can break down a lot of bigger square roots just by looking for those things. And it's a process, right? You might have to do like, okay, there's a 4 in this. Oh, now there's another 4 in this. Oh, now there's a 9 in this. So it might take you a little bit to get them down, but you can break down bigger square roots without having to guess necessarily the biggest square root that was in. Yeah?
Do we have time to work on it?
Yeah, I'm going to give you a little time to work on that. Okay? So the ones that you kind of have to look out for are 25, 49, 121. But if you think about it, that really does eliminate a lot of things that you might have been looking for. Right? Now all we really have to look for is 4, 9, 25, 49, 121, and I doubt that you'll see any bigger than that.
144.
So 144 would have 4s in it, right?
Okay. Would you see it often?
Probably not. But then 13 is like 169. That's another one that you're not going to see any of these little hints in. So, again,